Hello everyone, myself Feroza D. Mirajkar. Today we will see a program on how to convert a given number from binary to gray. The logic behind converting a binary number to its gray code is based on how gray codes are defined. That is, each successive value in gray code, it differs by only one bit from the previous value. And the key which is used to convert is the XOR, that is the exclusive OR operation, in order to determine the relationship between the adjacent bits in the binary number. This is the formula in order to convert the binary number to the gray code, that is binary to gray conversion formula. So suppose we are having a n bit binary number, that is bn, bn minus 1, bn minus 2 up to p0. For this, the gray code or the gray number will be gn, gn minus 1, gn minus 2 and g0. The most significant bit of the gray code, that is gn, this one will be same as that of the most significant bit of the binary number bn. So whenever we are converting any gray binary number to a gray number, the first bit, that is the MSB bit of the gray number, will be same as that of the MSB bit of the binary number. And for all other remaining bits, that is, this will be the formula which we'll be using. That is, gi is equal to bi XOR bi plus 1 for all I is equal to n minus 1, n minus 2 up to 0. The gray code, it is a binary numeral system where the two successive values differ in only one bit. And these are the two steps which are being used to convert a binary number to a gray number. The first is the MSB bit remains same, and the second is using the XOR operation. That is, here the most significant bit of the gray code is same as the binary number, and each subsequent bit, it is calculated by XORing the corresponding bit of the binary number with the bit to its left. Next is the logic for the program. Here, the first step is loading the binary value. So the binary number, it is fetched from the memory and stored in the accumulator. Then another copy is made in the register B to retain the original binary number for later use. And the second step is rotate the binary number. Here we'll be using the RRA instruction, which performs a rotate right operation on the binary number, and each bit is shifted one position to the right, and the least significant bit, it is moved to the most significant bit position. This creates a shifted version of the binary number. The next step is applying XOR operation. So here we'll be using XRL A comma B instruction, which performs a bitwise XOR between the rotated value which is in the accumulator and the original binary number which will be saved in the register B. Here the MSB remains same since it is XORed with 0. Each subsequent gray code bit, it is calculated by using the formula. Then we'll be storing the result, that is the resulting gray code, it will be stored in the memory at the next address. So these are the steps for the program, that is converting a binary number to a gray number. Now here you can see how the binary code, it is converted to gray code. This is the binary number, that is 100110. Now we want to convert this binary code to a gray code. For that, the MSB remains same. The MSB of the binary code and the MSB of the gray code, both are same. Now for the subsequent bits, what we'll do? We will take the MSB of the binary code. It is XORed with the next bit, that is 0. So 1 XORed with 0 is 1. Now, to obtain the next bit in the gray code, we will take the next bit, that is this 0. It will be XORed with the next bit, that is 0. When 0 and 0 are XORed, you will get a 0. So here we are getting 0. Similarly, you have to do it for all the subsequent bits. Then we will get the gray code for this binary code as 110101. Okay, this is how you get the gray code from the binary code. Now here what we are doing is, suppose here I have taken the same number 1000110. What we have to do? We have to rotate right, okay, by 1 bit. So here what we are doing, this 100110, I have shifted it. That is, here we are performing a rotate right operation. So here it will be 100110. This position remains vacant here. Okay, it is empty because the MSB of the binary and the MSB of the gray code, it must be same. Fine. Next, what we have to do? Here we have to XOR this. Okay, 0 and 1 XORed, we get 1. 0, 0 is 0. 1, 0 is 1. 1, 1 is 0. 0, 1 is 1. And because we have shifted, this 0 remains here. So for that, you are getting one extra bit here. You have to discard that. So what is the output? The output is this. That is 110101. Then we'll see one example here. Here we have taken a binary number 1010, which is the decimal 10, and we have to convert it to gray code. What is the MSB of this binary number? It is 1. So the gray code will be having the MSB as 1 itself, because the MSB of the binary number is 1. Now for the next bit, what you have to do? You have to take this MSB of the binary number, okay, that is 1, and next bit of this binary number is 0. So these two we have to XOR it. So 1 XOR 0 is 1. So here we have placed 1. Now next bit, we have to take the current binary bit now. This is the current binary bit, okay, that is 0. That has to be XORed with the next binary bit, that is 1. So when you XOR these two, 0 XOR 1 is 1. So it is 1. Now to get the last bit of the gray code, again you have to go for the current binary bit, that is 1. That has to be XORed with the last binary bit, that is 0. So here you will get 1 XOR with 0 as 1. So your resulting gray code is 1111 for the binary number 1010. This is the gray code table. Okay, just a minute. I will minimize it. Okay, so this is the gray code table which you will get after converting binary to gray code. Here for 0, it remains same. For 1, binary code is 0001. So gray code is also same. For 2, for decimal 2, binary is 0010, and for gray it will be 0011, and so on up to 15. Now we will see the program. So this program, it converts any binary number which is stored in the memory to its corresponding gray code, and it stores the result in the next memory location. So first is the initialization process. Here we are using ORG0000H. This indicates the starting address of the program in the memory. Next instruction which we are using is move R0, #30H. This instruction, it will load the memory address 30H into the register R0, pointing to the location where the binary number is stored. Now next is, we have to load the binary number. For that we are using the instruction move a comma at r0. This instruction moves the binary number stored at the memory location 30h into the accumulator, that is accumulator register, that is A. Now the next instruction is move b comma a. This instruction, it will copy the value of A into the register B, and the value of A will now be used for the gray code conversion, and the original value, it will be stored in the register B for further operations. Now next is we have to shift the number to right. So for that we are using this RRA. This instruction, that is the rotate right instruction. This instruction, it will perform a rotate right operation on the accumulator A, and this will shift all the bits of A to the right by one position, with the carry being moved into the leftmost bit of the accumulator. After this operation, A, that is the accumulator, it will contain the shifted version of the original binary number. Now next we have to perform the XOR operation by using this XRL A comma B instruction. So here this XOR operation, that is the exclusive OR operation between A and B, is performed, and this operation, it will help to generate the gray code, as the gray code is formed by XORing the original binary number with a right shifted version of itself. This gives the correct gray code representation. After this we have to store the result. So for that you have to use the instruction increment R0. That is, this increments the register R0. Okay, that is R0 is 30h, next it will be 31h. So it points to the next memory location, that is 31h. After that move at R0 comma A. Here the gray code value will be stored in the accumulator. It is now returned to the memory location 31h. For now we have the gray code converted value in the accumulator that has to be stored at 31h. So by using this instruction move at R0 comma A, that will be stored into in that location, that is 31h location. Then we have to end the program. We have to use this instruction h colon s jump h. So this instruction will create a infinite loop in order to halt the program, preventing it from the executing some further operations. Now here we have loaded 1010 into A and B. Okay, till here, that is we have loaded 1010 into accumulator A and register A, and that is accumulator A and the register B. After that we have to perform a rotate right operation, that is rotate right. This 1010, it will become 0101. Then you have to perform XRL operation. Okay, here A comma B. So what you have to do, you have to XOR these two, that is 1010 and 0101. So your result will be 1111. After that what you have to do, you have to increment R0. Then you have to store this value, that is 1111, at the next memory location, which you have got after incrementing R0, that is 31h. So you have to give the input 30 at memory location 30h, that is 1010, and output you will be getting at 31st location. So the output will be 1111. So we'll revise the steps for conversion. What we are doing, we are loading the binary number from the memory into the accumulator. Then we are copying the same number into the register B. After that we'll perform rotate right operation, that is rotate the binary number in accumulator to the right. Then we will perform a XOR operation on the rotated binary number with the original binary number in order to get the gray code. After that we have to store the gray code at the next memory location, and we have to halt the execution with an infinite loop. Now we will see the execution of the program. So here we will open the Keil software by double clicking on the icon of the software. Now go to project, new MuVision project. I will use the previously used project, Alice. Yes. Select the device, microchip. Click on the plus symbol. Search for 8089C51. 8089C51. Then click on OK. Click on No. Now go to File, New File. We have to write our program here. I'll copy the program. So this is the program to convert a binary number to gray code. That is a gray number. Sorry. Okay, now we'll save it. It is binary to gray, so I'll write it as B to G. Okay, I'll write small b to G. You have to save the program with .asm extension save. Now target has been created. Click on the plus symbol, then right click on source group 1 and click on add existing files to group source group 1. Now type your program name B2G. So this is b2g.asm. Select that, click on add, click on close. Now see whether this program has been added to the source group 1. Click on the plus symbol. Here you can see your program has been added. Now we'll go to project. Click on build target. You can see there are 0 errors and 0 warnings. Now go to debug. Click on start or stop debug session. Here click on OK. Here we require only one memory window. Now we have to give the input at 30H location, 30H location, and output will be displayed at 31st location. So I'll write I'll type here I:30H. I'll give the input here at 30H location as 1010. Sorry, it is 10. 10 is 0A. I'll give 0A. Or I'll give 6. We'll see what we'll get. 6. Debug. Click on debug. Click on run. So you are getting here it as 5. We'll see for another one. I'll stop this. Now go to debug. Click on start or stop. Okay. I will give the input as 4. We'll see what we'll get. Click on debug, run. So 6. So this is our program for converting the given number, that is a given binary number, to gray number. Okay. Here we have the program. This is our program. Okay. You can try this for other inputs also. Hope you understand the program. Thank you.